Hello friends, it is a NPTEL database management system week 5 assignment of 2019. I am going to explain each of the question in a detailed way. Please listen carefully, try to understand and get maximum benefit out of it. And if you have any doubt, please feel free to put your doubt in the comment section. Now listen, coming to the first question. Question number 1. It is given, suppose that the record of a customer in XYZ bank is 300 bytes. So size of the record is 300 bytes. Each block contains 5 such records. That block, say this is a block. This block contains 5 records. Say record 1, 2, 3, 4 and 5 records. The data transfer rate of the disk is 75,000 bytes per second. Data transfer rate is 75,000 bytes per second, means per second it is transferring 75,000 bytes from disk to memory. And seek time is 20 milliseconds. Here it is given seek time. What is seek time? The time it takes to reposition the disk arm over the corrected track. Means because disk is having many tracks, so arm should come to the corrected track. So it will take 20 milliseconds. That is a seek time. The disk unit rotates 72,000 RPM. We call revolutions per minute. So means disk is rotating from per minute, it is rotating 72,000 times. That is what we call revolutions per minute. Now question is, how much time approximately is required if a customer wants to know his or her balance? Customer wants to know his or her balance. It does mean that how much time it will take to know the balance of a customer. We call it is access time. We call it is access time. Now coming to the formula of access time is access time equal to seek time. I'm writing clearly. Access time equal to seek time plus rotational delay plus block transfer rate time. I'm writing clearly. Rotational delay plus block transfer time. Block transfer time means the time it will take for the block to transfer from disk to memory. It is block transfer time. Now we'll understand each word. What is seek time? The seek time specifies the time it takes to reposition the disk arm over the corrected track. Among the many tracks, disk arm is going to be positioned into the correct track. That time is called seek time. And second one is rotational delay. We also call rotational latency. The rotational latency says the time it takes for the sector to be accessed. Means whatever the sector to be accessed to appear under the head. Say means it may have many sectors. Suppose I wanted data which is there in this sector. So disk arm come to this sector. That is called rotational delay. After it comes to that particular track, now disk is to access data from this point. So this is called seek time. And next, block transfer time. Block transfer time means it is a time that takes to transfer one block of records from disk to memory. Now these three things we have to find, and then we add all three together to give the access time. So means first the respective track has to be accessed. That is called rotational delay. After respective track is accessed, now respective position it should come the disk arm. That is called a seek time. And after it positioning, the particular block of records, means whatever the block of records is to be transferred from disk to main memory. This is called block transfer time. Whenever it moves to main memory, the customer can access the data. That is called access time. Okay. Now seek time it is already given. What is the seek time given? The seek time given is 20 milliseconds. Because it is given 20 milliseconds, now we will convert into seconds. How we can convert 20 milliseconds into seconds? 20 by 1000. The 20 by 1000 equal to 0.02 milliseconds. Now second thing, we have to find the rotational delay. We call rotational delay or rotational latency. Now how to find rotational delay? Rotational delay we can find by using a formula called 1 by 2r. What r indicates revolutions per minute. This is 1 by 2r minutes. Okay, this is 1 by 2r minutes. Now I have to convert into seconds. So that it is 60 by 2 into r number of revolutions per minute is 72,000. When you solve this one, 60 by 2 into 72,000 seconds, we call it as a seconds. Now it is converting into seconds, will give you a value approximately 0.00416 seconds. Okay, this is a rotational delay. And third one, we have to find block transfer time. It says one block of records to be transferred from disk to memory. How much time it will take after it finds the particular block. That is, one block contains how many bytes of memory? One block contains 5 records and each record is of 300 bytes. So that one block contains 1500 bytes, but per second it is going to transfer 75,000 bytes. So that to transfer one block, it is going to take how much time? 1500 means 5 into 300, 1500, which is a block size, by 75,000, which is equals to 0.02 seconds. Okay, means to transfer one block it will take 0.02 seconds. Now the question is, what is the access time? The access time now it is equals to 0.02 seek time plus 0.00416 rotational delay plus 0.02 seconds, which is required for block transfer time. When you add all this, you will get 0.04416 seconds. But question is given in milliseconds. So if you convert into milliseconds, so it is about 44.16 milliseconds. We can say approximately it is 44 milliseconds. Approximately we can say that decimal points I am not considering. It is coming 44 milliseconds approximately. So the answer for the question is option B, which is 44 milliseconds. Coming to question number 2. Question is, which read level is appropriate for storing the log file of a ticket booking system? Storing the log file of a ticket booking system where huge database update is required. Huge database update is required. Now, what is RAID? RAID is redundant array of inexpensive disks. Redundant array of inexpensive disks. This is RAID. Now, RAID is having level 0, 1, 2, 3 up to 6 we have. And each level is having its specificity. Now, level 0 is used for data safety. Means when data safety is a high priority. When data safety is not important, then level 0 is used. Okay, and level 1 preferred for applications for high data update environments. High data update environments. When higher updates are required, so we go with the level 1, high data update environments. And level 5, it is preferred for applications with low update rate. Low data update environments, we go with the level 5. And level 6 is rarely used. Means generally this level 6 RAID is not used. We call it is rarely used. Now, what is the question? Here the key point for the question is huge database update is required. Now, level 0 is where data safety is not required. Actually, this is ticket booking system requires high security, because ticket booking may involves credit card details or debit card details, payment related information is required where data safety is needed. So level 0 is outdated. And level 5 is where low data update environments. When in the case of low data update environments, level 5 is used. but here clearly given huge database update is required. So level 5 is not the correct answer, and level 6 generally will not be used. It will be used rarely for some different applications. So that we go with an option level 1, and it is clear that level 1 is used in an environment where high database update is required. So answer for the question number 2 is option B. Coming to question number 3. Question is, which of the following defines the way a web server communicates with external applications? A web server communicates with external applications. Now we know it is a direct question. CGI, we call it as a common gateway interface. I'm writing clearly, common gateway interface. CGI is a standard interface between web server and application server. We call external applications. Between them, CGI is used. So it is a direct question. Answer for the question is option B, CGI. Now we'll look for other options. Here HTTP is called Hypertext Transfer Protocol, and HTTP is a connectionless protocol. Actually, HTTP is a connectionless protocol. When a HTTP server receives a request for a document, it executes the program and sends back the HTML document that it is generated, and it is a protocol, so that it is an option A is incorrect. And SMTP is called Simple Mail Transfer Protocol, SMTP. It provides connections to the mail server, so it is incorrect. And TCP/IP. TCP/IP is a networking protocol that allows two computers to communicate, so it is also incorrect. And it is a direct question. Answer for the question is option B. Question number 4. What is the availability of a DBMS? Availability of a DBMS with the following reliability figures. That is, mean time between failure equal to 42 days. Mean time to repair is 10 hours. The question is, what is the availability? Here the formula of availability, which is equals to mean time between failure by mean time between failure plus mean time to repair. Mean time to repair. So what is mean time between failure, MTBF? It is the average time between failures. It is I'm writing clearly, it is an average time between failures. Between failures, what is the average time? This is called mean time between failures. And MTTR, we call mean time to repair, is the average time. It is the average time taken to repair the system after a failure. Average time taken to repair after the system failure, after failure, is called MTTR. Now here it is given, MTBF is given, MTTR is given. Now we calculate directly. Now MTBF equaled 42 days, and mean time to repair is given 10 hours. It is days, it is hours, so that we will convert both into hours. That is 42 per day. There are 24 hours, so that mean time between failure is 42 into 24 hours by mean time between failure, that is 42 into 24 plus mean time to repair, that is 10 hours. When you solve this equation, we will get 99.9902. It is given in percentage, so that will make it into 100. When you solve this, we will get 99.02%. So 99.02% means that is an answer is option D. Question number 5. Which of the following represents uniform resource scheme, uniform naming scheme for locating the resources? For locating the resources, we use URL. We call uniform resource locator. As we know that uniform resource locator and uniform resource name are called uniform resource identifier, URIs we call. There are URIs either could be URN, uniform resource name, or URL, uniform resource locator, or both? So that answer for the question is URI, we call uniform resource identifier. Here URI can be classified as URN, URL. URN is called uniform resource name. It is for identity. Okay, it is for identity. URL is for locating that resource. It is for locating. Because my question is locating the resources, so that it is URL, and URL we also called URI. So the answer for the question is URI. And option B, domain name, web name, resource name are incorrect. Let us an example. Suppose I do have a URL http://www.acm.org/sigmod something. Here the first part, this one HTTP says we are accessing the resource using a protocol HTTP. And the second part will specifies the unique name of the mission on the internet. This is acm.org. And the third one, which is specifying the document within the mission. This sigmod is called document within the mission. We call it as domain name, web name, resource name, right? We call this is domain name, or we call web name. That's why it is incorrect. And resource name also incorrect. It's correct. URI. This is completely is required. So answer for the question number 5 is option A. Question number 6. In a hospital, there are various departments. Each doctor is associated with one department. A patient gets registered to a department under one doctor in that department. It may be required that he or she may be treated by other doctors of same or different departments. So doctors suggest various tests for the patients. Those are noted along with their reports. Question is, if you want to design a schema for the above system, what are the possible entities? The entities are identified by using the nouns. Noun could become an entity. Means noun is a basis to become an entity. Now, it is clear that doctor is a noun. And this statement says some information is needed about the doctors. And what we understand with this para is it is to show some information about doctors and their patients. So patient is required. Let's say report and test. Here a test is suggested to the doctor. If a test is suggested to the doctor, test could be a relationship, we can call attribute, and after test reports will come based on the test conducted. That is the meaning of after diagnosis some test will come, some results will come. That is called reports. Reports can be an attribute also. Okay, now see, the question is, if you want to design a scheme for the above schema, what are the possible entities? Now I can conclude that doctor and patient are the possible entities, and report and test could be an attributes, or we can say a relationships possible. More detailedly we will go. What is given? Hospital, there are various departments. Each doctor is associated with one department. Doctor could be one entity set. Entity set in ER model represented with rectangle. Doctor associated with departments. Say here I can show some relationship between doctor and department. That relationship I am calling associated. Doctor associated with some department. So doctor and department are the entity sets. Between them we have a relationship associated. Now we'll continue. A patient gets registered to a department. Here I will add one more entity set we call patient. Between patient registered to a department means between patient and department I can have some relationship. Registered, okay, register is a relationship between department and patient, because here is a statement, patient gets registered to a department under one doctor in that department. It may be required that or she may be treated by other doctors of same or different departments. Means a patient is treated by doctors of same department or other departments. Doctors suggest various tests for patients. Between doctor and patient, I can have one more relationship because doctor is suggesting some test to the patient. Suggesting test, I can take it as a relationship in doctor and the patient. Those are noted along with their reports. Those are noted along with their reports. This is an ER model, I can say. In this ER model, based on the statements, I conclude that doctor is an entity set, department is an entity set, and patient is an entity set. These reports, after test conducted, the reports I may note it as attribute. So this is incorrect. Test is possible to become a relationship because doctor suggests test to the patient. Test is a relationship. The possible entity sets doctor and patient. So answer for the question 6 is both B and C possible. Number 7. In hospital, there are various departments. Each doctor associated with one department. A patient gets registered to a department under one doctor in the department. May be required that or she may be treated by other doctors of same or different departments also. Doctors suggest various tests for patients. They are noted along with their reports. Now question is, if the primary key of the department is department number, so it means department is one entity set. Doctor table is here, doctor is another entity set, is doc ID. Patient table is patient ID, the primary key attributes. Question is, what is the minimum choice for the primary key of test table? What is the minimum choice for the primary key of the test table? That is a question. Here, the previous question itself, we have drawn a diagram for this. Test is a relationship between doctor and patient. We have seen means a doctor entity set and doctor suggesting some test to be conducted patient. So test is a relationship between both doctor and is what is the minimal choice primary key of test table. Here, if I am converting the relationship into a table should have attributes which are primary keys of both participating entity sets. Now doctor is having doc ID is a primary key. Okay, doc ID is a primary key. In the patient table, ID, that is patient ID, is a primary key. It is taken. Now test table should contain the primary key attributes of participating entity sets, that is doc ID, patient ID, doc ID and patient ID is required. Now observe the options. In options, doc ID, patient ID is there in the option A. So option A is the correct answer. Department number, patient ID, and kind friends, doctor is suggesting a test to a patient. Now test is a relationship between doctor and patient. So here department number is not required. This option is wrong. Similar reason we can give for this option. Similar reason we can give for even this option. Anyhow, test date is common for all of them. We can go with an option A. You may ask a question, sir, why test date is required as a key attribute? Then just we'll understand a small scenario. One, did some test, Dr. D1, 1st January, observed the reports. And based on the reports, patient 1 again suggested test by the doctor 1 next day. We can call 2nd February, 2nd John or 2nd February or something after a month. Now see here, patient ID and doc ID is possible to become a duplicates. Why? Because same patient is suggested same test by doctor. Means here the combination of patient and doctor ID is possible to become a duplicates. If two are possible to become a duplicates, it is no longer be a key. That will be making date also part of a key for the test table. So answer for the question is option A. Question number 8. Audit trail is a system to ensure security. Does it helps the system? Hence, audit trail is something related to finance. An audit trail is a step-by-step record. We can call it as a step-by-step record. Step record by which accounting data can be traced to its source. Means if something went wrong, again step by step accounting or trade data can be traced to the source, means to the beginning. So where it went wrong, where security breach occurs, that we can able to identify. An audit trail contains information about what is actually audit trail contains information about who performs update, this delete, other operations on the database. If it comes to the database, we can say in this way. With timestamps, means at what time that access or delete or update happened, that we have to maintain. Audit trail can be used to later detect if any security breach occurs. If any security breach occurs, then it is possible to detect it because we maintain audit trail. Look, option A, it is given, it is used to make backup copies. It is not for backup copies, it is for tracing back to find where it went wrong. Option A wrong. Be given, it is used to record the history of operations. Yes, perfectly right. Trail used to record history, like what updates are done, data is accessed, right? What data is deleted with respect to DBMS, we can say in this way. This information is required to be recorded. So there is an option B. For option C, it is used to restore lost information. It is not for restoration, it is for identifying the security breach. Option D given, it can be used to localize the source of an error. It is not for source of an error, so that it is an option D is incorrect. So answer for the question number 8 is option B. Number 9. To create and display a table in a web page. Create and display a table in a web page like the format, like the following. Now this is a kind of a table we want to display using the web page. This table HTML, right, as a table format, we use table ends with a markups table. Okay, and here the options we have border, margins and all. Here we can take border is, so it is a width of the border of a table. Always table to be defined with first the rows is represented with tr with td, means backslash td. Tr. A row may contains column, means this is a row, it may have many columns. Okay, it may have many columns. Column represented with td. The data under the cell we have to specify, and is with end up markup we call slash td. Okay, we use slash td for end up markup. Okay, so what is required? Table consisting of rows, and that rows consisting of columns. All is represented with the markup table and table end table, and represented with tr and tr, and represented with td and ntd. Now the question is, what will be the correct HTML code? Well, option A, look, table border equal to 1. Now table contains rows, tr with a tr. The rows consisting of columns. Columns is td, ends with td, means this is 1 td, td 3 4, right? And here what it is mentioned, td 101 104 105, means here representing the column, means it is representing data in this way, but only when it is used tr, data is to be represented in this way, horizontal way. Okay, not in the vertical way. So option A is incorrect. Table rows, but it is given columns, it is incorrect. See, table, okay, but again columns, it is incorrect. Now table rows, okay, this is horizontally, that contains columns. Now td sid, td is name, right? Now first is sid, second is sname, third is marks. First row is, it is first row. Second row is, what is second row? Again tr ends with a tr, and that first column is 101, second column nil, third column right. So that it is representing third and it is representing 4. So the 4 options, D is the correct syntax HTML code. So answer for the question number 9 is option D. Yeah. That a DBMS software uses most really used strategy, MRU strategy, recently used strategy, MRU strategy, buffer replacement policy. Further, suppose that the system allocates 4 free buffers. Free buffers means says one buffer block having 4 blocks, free buffer blocks for execution of a query. Let a query requires to access the following disk blocks to compute its execution. These are the disk blocks are given. Okay. Question is calculate the number of block replacements. What means block replacement? Suppose it is having some data, so Y, Z, W, some data is there. Next we have some new block has come P. This P is to be put up into the buffer blocks. P is not there, so that among X, Y, Z, W, which is the most recent block, that is replaced with P, called replacement. To re-record question number 10. Coming to question number 10, that AMS software uses the recently used strategy, MRU strategy, buffer replacement policy. Further, suppose that the system allocates free buffer blocks, means we do have 4 free blocks. All 4 free buffer blocks are filled, something like 1, 2, 3, 4. Our block has come, say, assume it is 5. 1, 2, 3, 4. Suppose 4 is the most recent one. This will be replaced with 5. This is what we call MRU strategy. Let a query reach to access the following disk blocks to complete its execution. These are the disk blocks are given. Okay. Let's calculate the number of block replacements. Suppose 1, 2, 4 is used, put up, and then later 5 has come. Then there is no place. Then we have to replace the most recent buffer, 5. 1 block replacements. Like such, how many block replacements are required to complete the query is the question. To understand this, I will be writing the given buffer blocks, disk blocks, in a neater way. That is what we have: 7, 5, 1, 2, 3, 1, 2, 1, 7. Here how many? 4, then 4, 8, 20. Okay, we have 20 buffer blocks are there. What it is given? 4 free buffer blocks for execution is given. Now look at, I do have 4 free buffer blocks. Of 7 is stored. Here it comes. Okay, 7, then 5, 1, 2. Okay, this is 1, 2. After storing 7, 5, 1, 2, next 5 has come, and 5 already there in the buffer block, so that it doesn't require any replacement. Next 3, is 3 is already there in the buffer blocks? No, because not already there. It has to be replaced with most recent one. Among 2, 1, 5, 7, which is the most recent one? 5, right? The most recent one is 5. So 5 is replaced with 3. So buffer block becomes 7, 3, and 1 and 2. Now most recent one now 3. Next, again 5 is not in the buffer blocks, so that recent one to be replaced with 5 becomes 7, 5, and then 2. This is the first replacement. This is the second replacement. Okay, 5 replaced with here. 4 is also not there. What is the most recent block? This one. Again, it is a third replacement. There is 7. That 5 is replaced with 4. It's about 2. Okay. Next 2 already there. This is a most recent buffer block. Next Now where 3 is to be replaced? 3 is to be replaced with 2. There is a next replacement. 7, the 2 replaced with 3. The replacement. Now which is the most recent one? 3. Now 5 is not already there. Now replace with 3. Sums. That 3 replaced with 5. None. 4 and now most recent one 5. Now again 3 not present. So 3 is to be replaced with this. This is a fifth replacement. Now we can say that 5 is replaced with 3, so that it becomes 7, 4, 2. Most recent is 3, that is replaced. It is a sixth replacement that will be replaced with 2. Now 2, 1, 4 and 7. This 1 already there. Next is 2 already there. Next 5. Now it's to be replaced with most recent one. What is the most recent one? 2. This 2 is to be replaced with 5. 5, 1, 5, 7. This is the seventh replacement. Next, already there. 7 already there. 5 already. 1 replacement. Actually, I didn't count it. This is the eighth one. So total many replacements we have? 8 replacements. See, 8 replacements.